Hello everyone and welcome to this webinar about EcoProfiles. So there is a lot to say today, so without further ado, I will jump to the presentation and to today's agenda. So we'll start with a brief introduction about ourselves and our company, but then we'll jump to the core about EcoProfiles, so what they are, what is the methodology behind EcoProfiles, how they were created, and we'll have a really useful and practical showcase within openLCA, so our open source software, and then a final chapter about the outlook of the use of EcoProfiles. Of course, we leave enough time at the end for a Q&A session. And on this note, please feel free and actually do write your questions on the Q&A section here in Teams. So about ourselves, my name is Chiara De Grandis. I'm a sustainability consultant at GreenDelta. And actually, together with Julia, I also take care of communications. And indeed, we have also Julia, Max, and Jonas here today with us. So they are the experts of EcoProfiles as they worked on a PRIMUS project. So the context in which indeed EcoProfiles were created. But I will tell you more about that afterwards. So a quick overview of our company, GreenDelta. So we are mostly famous for our software, openLCA, an open source and free software. We also developed other tools such as online LCA and openLCA. But indeed, like we said, we are also sustainability consultants. Indeed, we follow some both private and public and EU-funded projects. You find some names here, among them PRIMUS, that I already mentioned, and another one we will mention throughout the presentation is STOP, so also remember this name here. And we also take care of database development, that you can find on openLCA Nexus. I just say in case you're interested in social LCA, we had a nice webinar about Silka quite recently that you can find in YouTube, and we'll have another one next week about SOCA and its updates on Wednesday 29th. I think I said everything. Again, write your questions, and now I will leave the floor to our experts about EcoProfiles.
Yeah, hi everyone. I see there's a great interest in this topic, so it's nice to see. My name is Jonas Hoffmann. I'm working also at GreenDelta as a sustainability consultant and researcher. And talking about EcoProfiles today, maybe if we see the next slide, I can explain a bit the background. So the background in general, in this particular, we had a research project in the field of plastic production, and plastic production is gonna triple until 2060. And overall, it can be seen also as problematic because 50% of the global greenhouse gas emissions can be derived to this sector. Plastics are at the moment very often fossil-based, and their sustainability can be quite well assessed and investigated by performing life cycle assessments of plastic products to understand also the environmental implication it has to produce and those plastic. There has been a long-standing tradition for EcoProfiles, which is a term being used for life cycle inventories. It's kind of the recipe to produce plastics derived from Plastic Europe. So this is already a long-standing tradition that they provided the first of this kind, life cycle inventories, which normally are built in the cradle-to-gate fashion. And they are, in that logic, they are aggregated. So if you, for instance, are interested to use polystyrene, like a kilogram, Plastic Europe made the job to collect all the producers' data to give you the inventory to produce a kilogram of polystyrene. Fortunately, for a long time, they have been aggregated, though it presents a nice overview because otherwise, because it's a very industrial product, people would not have the data. And that's, of course, a bit of the limitation to that. Those have been provided by Plastic Europe. I hope they're also present today. And there is a methodology, and then per product, there's also then a description of the product itself, the technology, but all the inputs and outputs, they are, though, in an aggregated fashion. Yeah. In this project, we looked a bit on something different, but we'll explain it a bit later. Issue is also, of course, they have been not only the inventory, but also the life cycle impact assessment. And then they are fixed to one LCA method at that moment, but they're also reported so that at the end of the day, people who use those data can directly work with the data and the impacts. yeah, if we see on the other slide, so this is, some people have seen this maybe already. This is a very nice page from Plastics Europe where you can directly click on the chemical you want or the polymer you want and derive the ecoprofile. I think it's quite important to mention that they very often have good industrial data. So means, for instance, if you go for styrene, all the big steam cracker companies, they put the data together and then you have a quite good industrial average of the production of styrene all over Europe. So that's a bit the spirit, and it gives a lot of LCA databases good background to produce it, otherwise it would not be able to have this data. But though it's a bit limited because still they're fully aggregated and it's hard to investigate how those got produced and also to update the data. It's not really possible to that extent. Yeah, for instance, you can also load it easily in openLCA, any of the, because they come with ILCD files, and then you will see something like this, which here is ABS in a production, and then you have a long list of elementary flows or also waste flows here, and then you can see, for instance, hydrogen 3 is there, and you're, okay, interesting, but of course it's the whole supply chain aggregated into one data set. Yeah, if we go to the next slide. Which was a bit the focus of the research project we conducted, is that Plastic Europe's obviously focus on primary production of polymers. So this is for mostly polystyrene, PET, all in this direction for primary things. Elsewise, we have a big issue that for recycled materials, there was a lack of data existing. So there was not so much data being there. If you want to use recyclate in LCA, you had not that much data. That's, of course, a problem. You can also see in the charts we provide on the right side that numbers of ecoprofiles, so the average life cycle inventories for European production, is limited to some polymers. And even in the most competitive database, until most recently, we only had 2 recyclates existing. So of course that represents a big problem if you want to simulate using a recyclate in your product system. There was no data available. So this was a bit also why we now changed it a bit. Also for the ecoprofiles themselves, at the moment, or the most common version is the aggregated version, which limit actually the transparency, but also updatability. Like for instance, electricity mixtures change over time, could also do prospective LCA, and hence this is not allowed because it's fully aggregated. Yeah, and this was a bit the focus on the PRIMUS research project, where we focus on high valuable recyclates, so-called recycled ABS, recycled HIPs, recycled polypropylene, to build a novel kind of ecoprofiles. So same logic, but providing disaggregated data to give people the idea about how those things are actually produced and the environmental impacts which can be assigned to them. And this helps a lot to later on then also use recycled material in further studies. Julia, do you want to continue? Or
Super, thanks, Jonas. Yes, so I will be then speaking about the new, or start speaking of the new ecoprofiles developed as part of this research project, new ecoprofiles for recycled plastics, and we will speak about the methodology later, but already so that you know what we outputted out of this work is LCA datasets for recycled plastics in Europe, and they are available in these formats. So we have ILCD, so LCA datasets in the end follow LCA data formats. ILCD is the format suggested by the European Commission, and so therefore we have it in ILCD format. We have it also in JSON-LD format, which is the data format that's compatible with openLCA. And it's an exchange format that maybe can also be imported in other software. It's very rich. And then we have them in PDF. So you don't have to be an LCA expert or work with LCA datasets in order to check the results and the inventory. They are available in PDF format too. And where to find them? They are all downloadable in our marketplace that we use for openLCA, which is openLCA Nexus. Here you need to create an account and then just download them. So they are available for free because they were developed as part of the PRIMUS research project. And there's 2 options available. One is connected with the EcoInvent supply chain. So we used EcoInvent as the background database. And then this, you must have the database license in order to download the datasets. But we also have made available a fully free downloadable version, which counts with the inventory. Okay, so this is information that you don't need a license to obtain, or like to pay for a license to obtain. There's of course a end of user license agreement, but this is nice and available for free. This can be imported in EcoInvent if you want to connect it to the supply chain, but it's also available for you to see. And this includes ILCD, the PDF, and the JSON LD formats. Also in the same page, in a different tab, in the Documents tab, you can see the methodology, which Max will further explain, but you can see this in a nice document here in the document section. And also we've uploaded all of the PDFs in the document section so that indeed you don't have to even create an account to download the PDFs. And with this, we hope to contribute to research for the uptake also of recycled plastics by being able to use them in assessments, sustainability assessments. We hope and we're sure this will help. So very briefly, in summary, recycled plastic eco-profiles, they are cradle to gate and also available gate to gate dataset for recycled plastics in Europe. The primary data was collected in 2024 by Plastic Recyclers Europe, which is an association for recyclers. We worked with them as part of the project. Again, publicly available and for free. Very important to mention the PRIMUS project. In the end, it's funded by the European Union, and it's just finished in April this year. It was 3 years of hard work with other consortium members from the whole of Europe, research institutions and companies, recyclers and Plastic Recyclers Europe. It focused on improving plastic recycling industry with new polymer recycling technologies. The case studies were focusing, and our pilots were focusing on automotive and home appliance applications, also food contact, debromination strategies, etc. So if you're curious about the outcomes of PRIMUS, it's very easily findable online. The project is closed and deliverables should be already available. The ones from us are already available, but if they soon shall be available if they're not. And with this, I pass on to check more deeply the methodology with Max.
Thank you, Julia. I'll take it from here and I'll present the methodology that we use to create these data sets and also display some underlying assumptions that we had to use, discuss a little bit of the data that we used to create these these eco profiles. And yeah, thank you all. I'm just also so you know, I'm Max Springman. I work for GreenDelta as a sustainability consultant, as Chiara already introduced. So let's get into it. So first, what I want to do is I want to define the scope of the eco-profiles that were created within the PRIMUS research project. So first of all, the produced data sets are created for mechanically recycled plastics that were produced at European member facilities of Plastics Recyclers Europe. So for mechanical recycling, I've also included an outline in a figure that you can see here. So just to give you an overview, so typically mechanical recycling may be composed of the processes that you can see outlined here. So the raw materials that are produced from the waste streams first require a collection effort that then is followed by a sorting in the sorting plant and just in the sorting plant. And then after that, they are transported as clean streams to recycling plants where they are reprocessed to finally produce regranulates that can be used to replace primary plastic inputs then. So now you have an idea of what the mechanical recycling actually encompasses. All of these different steps may differ between different facilities. and they are not. This is not a general, basically, not general flowchart that applies to every single facility that was observed or that data was collected for, but this is just a general outline of what mechanical recycling can look like. So what did we actually produce data sets for? So you can see a full list of polymers here that includes polymers such as ABS, HDPE, HIPS, LDPE, mixed polyolefins, polyethylene, terephthalate, and so on. And for all of these different polymers, we produced a total of 50 EcoProfile datasets, which, as Julia already mentioned, you can now find on our distribution page, openLCA Nexus. So I hope this gives you a general overview of what the scope of this project has been and what EcoProfiles are available. And let's get into some more details, starting with the data collection. So you might be wondering what data actually underpins these efforts. So in total, we used data from 22 recycling sites that were situated in 9 different European countries. On the right over here, you can see a figure to give you an overview of these. Basically, the darker shades signify a larger number of facilities within these different countries, whereas lighter shades signify a smaller concentration of facilities in that country. So for all of this data, we compared the installed capacity of the facilities that we had data available for, and we were able to achieve a coverage ranging from 2.8% to 29.6% of the total European recycling capacity available according to Plastics Recyclers Europe. So the data that we collected either produced granulated polymer outputs or polymer flakes that then would need further processing before being used in production processes again. But in general, the data that was available to us was mostly comprised of waste streams such as household waste, industrial waste, some electrical waste as well as waste vehicles. But for most of these, we did not have specific data that differentiated the inputs and outputs by the different processing streams, so we were not able to model by the different waste streams in the end. So you will see an aggregate result for each polymer. So another limitation on data that we had was that we had no data on the specific quality of the recyclate that was produced. So we kind of used the proxy of only producing granulates and flakes here. Basically, the data that was contained in most of the data sets contained things such as washing chemicals, inputs to the flotation, so for density separation of plastic streams, then basically also water that was used for density separation, as well as energy used for drying or for extrusion, for instance, as well as transports within the facility, but also to the facility. Lastly, something that was not available through primary data was data on collection and sorting. And as Julia already pointed out, we have 2 configurations, both cradle-to-gate and gate-to-gate. And cradle-to-gate datasets in the end contain this data for collection and sorting as well, which we modeled based on a secondary source. So now that you know how the data looks, I would like to take you into the first assumptions and the principal modeling approach. So the first very big assumption that we have made is that basically we apply a cutoff between the first and the second life cycle of these polymeric materials. So you can see a figure over here that just gives a very, well, not very detailed, but just an overview of the whole plastic life cycle. So we would have the primary plastic production first, and the manufacturing and the use phase and the disposal, of course. And all of these processes are basically cut off from our modeling efforts. And we just start from the generated waste, which is then collected and sorted for some EcoProfiles, and then also we undergo some general steps for plastics reprocessing. Finally, then the use phase of this secondary material and the processing to a final product is also not included, but we have included some end-of-life options for basically for production waste that occur within these recycling facilities. Now, you probably know that recycling facilities rarely produce one specific output. So if I look at PET recycling, for instance, we would not have simply just PET as an output, but usually also bottle caps that are included, so HDPE bottle caps or PP bottle caps, which would then also be a valuable output of the recycling process. And to tackle these processes, we basically applied a physical allocation approach, which allocated the impacts based on the mass of the produced recyclate. Then lastly, the waste stream information that we had and that we could have used then actually got lost because in our approach, we produce average eco-profiles, and to confer to confidentiality with our data providers, we in the end aggregated at least 3 different facilities to create one eco-profile. Therefore, we do not have waste stream information contained within the eco-profiles, but we have documented which waste streams are contained within the production of one eco-profile. So for each dataset, you can look up which specific waste streams actually contribute to this dataset. Yeah. So also, we naturally define some system boundaries for our assessment. I already mentioned some things that we did, but just to give you an overview. So basically, Julia already touched on this, as I said. We have a gate-to-gate configuration of our system boundaries, which only includes the primary mechanical recycling processes that occur on site. But we also have a cradle-to-gate system boundary, which encompasses both the recycling processes that happen on site, but also the previous collection and sorting that, as I mentioned, we modeled based on a secondary source. And you can also see here that we used that basically for inputs to these processes, such as transport or energy production, or energy conversion, or raw material provision, we used a background database. In this case, it would be EcoInvent, that we then connected and therefore created a supply chain here. Another thing that is important to note is that some wastes that occur in a mechanical recycling facility actually don't end up are things such as metals or wood or glass, for instance, easily recyclable byproducts, then don't get treated at the end of life, but actually enter another recycling process. And for these materials, we applied a cutoff. So these are then modeled further outside of the scope of our datasets. So I hope this gives you a good overview of what we actually did methodologically to arrive at the datasets that we produced. And I want to touch on some more specific things that we did now, so to create these datasets. So here you can see a figure of the process that we applied to calculate the average contribution of different sites to a European EcoProfile dataset. So what we did is we had data from different production sites. So in this case, you can see that we have 3 different production sites that produce pellets directly, which are then used, and their output is scaled by the specific capacity that is related to the polymer that the dataset is for, at the specific site that is producing it, related to the total specific capacity for that recyclate that is available within the whole data set. So basically, you have a percentage contribution of each of these sites compared to the whole installed capacity that could produce this specific polymer here. So therefore, we create an average European data set from this. Something that you might have also noticed here is that we also include some flake production sites over here where we produce flakes. So now for these flakes, further processing steps would need to be included in order to create pellets. So we modeled a generic extrusion process based on the available data, and therefore also assumed that these flakes would be extruded and then produce pellets, which are also included in the final data sets. Now, this data set over here still contains all the information of which specific data is actually contributing to this. So if we had this production site and it was from, let's say, based in Germany, this one would be based in France, and we just use this data directly, it would be pretty evident which data actually comes from which facility, and you could easily re-engineer which was where. So in order to preserve confidentiality, what we did is we created a European EcoProfile dataset using the inventory data that was created through this process, and then connected it to different European background processes. Now, it may be interesting to you is how we did this in openLCA directly, which is we created models themselves and then used an aggregation process using parameters and dependent parameters specifically to calculate these specific capacities that we have here. Then, as not only average European datasets are available, we also have regional datasets available. I also want to outline the process that we applied there. So for the regional datasets, we simply had this European EcoProfile dataset, which is connected to average European processes. And then we used openLCA in combination with SQL or SQL, where we were able to change the processes that this dataset actually connects to in the background database. So basically, when you have a regional dataset, what you will see is that some of the inputs and outputs were replaced with regionally appropriate inputs and outputs, and therefore these are then basically re-regionalized to regions that actually produce these polymers as well. Now, I also want to show this in openLCA quickly, just for you to have a good understanding of what I mean by regionalization. So what we have here is one inventory for the production of 1 kilogram of PP. I think this is pellets in this case. It is. And then this is connected to the background database for specific processes. And you can see here that we have waste treatment processes that are connected here and electricity processes. For these, we have regionally appropriate datasets available in the background database, and therefore these processes are exchanged with regionally appropriate ones. So let's say we have the average European market for electricity that we have in our average dataset. Then if you looked at our French dataset, that would then be the French market for electricity. Okay, so I hope this lines out the regionalization that we performed. And I also want to go to some additional steps that we did in order to make sure that our produced results actually convey the information that we had as well. So once again, you can see the EcoProfile for PP over here. And you can see that we have a number of different inputs, and we have many different processes that actually contribute these inputs in the end, right? And what you may be wondering is, are all of these inputs represented in all of these processes? And that is not the case. So what we did here is we actually assessed the representation of different processes or different materials in different processes, and then created a data quality score based on that, which we then used to calculate an uncertainty value for each one of these inputs and outputs. And these uncertainty values we then used to apply the openLCA Monte Carlo simulation tool, which basically varied the inputs and outputs here randomly in the range of uncertainty, which we then used to produce mean values and standard deviations, and these standard deviations for each life cycle impact assessment category you can then find in the final result of the report that you'll see. So basically, just to make this a little less confusing, all of this was done to display that we have different inputs and the data quality that we have is not perfect. So basically, this data set that we're producing has a good representation, but some of the inputs that we are modeling, we could not confirm at the same representation as the whole process. So we want to display that we have a variation for results there. We want to basically preclude that for you. So another thing that we did on top of just the basic modeling of data sets is we also included a plastic littering risk for each one of the processes, where we did an estimation of using the Plex methodology. So what we want to estimate is both the microplastics emissions that might occur due to plastics recycling, and also the emissions of particulate matter which might be on site. but we would just wanted to have a basically worst case assessment of what could be the worst case of this eco-profile specifically as well. And therefore, we also applied this logic. And what it essentially does is you look at all the inputs of one process, then you determine the plastic content that of all of the total inputs of one process. You multiply this with a littering risk that is associated with the process, and then you arrive at a total amount of plastic litter that may occur. So this is more of a risk value than anything else. So please don't use this as a final estimate. So basically, what I just want to show here is also that we assigned the data quality to be very low, because this is just an estimate here, but just some extra details that you can find in the reports as well. Now, I also want to talk about how we actually validated and benchmarked our data sets. So this is not meant for comparison here. This is just to validate the data that we have produced by a basically by a known organization, and compare it to data set that we have available. As Jonas described earlier, we have some HDPE recycled data sets available in EcoInvent, and we basically used our EcoProfile and compared the results to that of that data set in EcoInvent, and we could confirm that it is relatively similar and we don't have any huge deviations here. Now, another thing that we did is we benchmarked basically our data set with that of primary plastics production, where we also used an EcoInvent process just to produce the final results as a comparison between ours and theirs, and see how well we performed compared to primary recycling with our data sets. Now, this whole approach was actually reviewed by one of our longstanding partners at GreenDelta, the VTT Research Institute in Finland. And basically, we had independent experts from the VTT review both the methodology, the individual reports, and finally also the data sets. And they verified both some process inventories and the LCA results that were produced and communicated in the reports. Now, this review as a whole confirmed the applicability of this method for future dataset production processes as well. And I'll tell you a little bit about that later. But for now, after all this technical information, I'm sorry, I hope I haven't lost you yet. But what I want to go into is a showcase of the whole approach that we actually followed and what is finally available to you. So to summarize this first, we have 3 types of information that's available to you. I think Julio already touched on this. So first we have a methodology document, which also describes in more detail all the things that I lined out earlier. And then we have individual reports. So for each one of the eco-profiles we produced, we have a report that shortly outlines the background, gives us a model description, and then finally also describes basically publishes the inventory used for the process and also the LCA results that we computed. You can also find datasets, as Julio described earlier, in the IOCD format as well as the JSON-LD format that can be directly used in further lifecycle modeling efforts. Now, I want to give some more details on the methodology report, just the structure, so that you already have a good idea of what you can actually find in there. So first of all, you will find an overview on the landing page where we have summarized some of our general introduction. And then you also have a background section where we have some background on all of the mechanical recycling processes that are occurring and that are common within industry for these recyclates, followed by a goal and scope definition for the dataset creation that we have here. There we go into details on assumptions, on specifically created processes, as well as our impact assessment that we have performed. Next, you will also see the LCI and the LCA results section where we just detail how the results are structured within the individual reports and why we structured them like that. Lastly, you will also find some descriptions for data quality, for the comparative analysis, and for the sensitivity analysis performed, where we just basically confirm the validity of our modeling approach. The last section that you'll also find in the methodology before the annex is the review section, where our partners, or where the VTT has produced an independent review report detailing their approach as well and their findings. Now, you know all the background information. I also want to cover what you can find in the individual eco-profile reports as well. So first of all, once again, you will find a landing page detailing some information for the eco-profiles, which is then followed by a brief summary of the same background information that we are providing within the methodology document. On the next page, then you could find a model description where we outline which waste streams are actually contributing, how much representation of the European recycling industry we achieved, and also just the general modeling approach that we have gone through, and as well as the system boundaries for this specific data set. Next, you can find an LCI result on the next page, where you can see the whole inventory that is used for a process. So if you did not want to create an account for openLCA Nexus, for instance, this would still be available to you, as we have provided the PDFs, and you could do your own modeling with this inventory result as well. We furthermore have some LCI results here using the cumulative energy demand method. And then we finally also have some LCA results that were created with the Monte Carlo simulation, as well as our assessment through the EEF method. Okay, that was a lot of input. So now what I want to do is to provide you with some guidance to actually using the data sets that we have produced. And for that, I will go into my browser and follow the whole process myself. So when you navigate to openLCA Nexus, what you'll be greeted by is this landing page. And then now you might be wondering where to actually find the eco-profiles on openLCA Nexus. So I would navigate to the databases section over here, just to give you an overview first. So down here, you can see a number of options, and a little bit down, you will see a PRIMUS icon at some point here over here, and this will be our recycled plastics datasets. If you click on browse here, you will end up at the same page that Julia detailed earlier. And here you can see the options of where to get the eco-profiles from exactly. So for the datasets, you will be navigated to the download section. And for these, we have two different configurations. As Julia already described, we have both disaggregated datasets that you could already see in the reports, but also an aggregated dataset, including the whole supply chain as a system process. So for this, a license of EcoInvent would be necessary, but these can be used freely. So I also want to show you where to find the individual reports quickly. In the document section, you will find the individual reports for some of the most important outcomes of the project for the average European data sets. And then you can also find the methodology over here. Now, what I want to show you is how to actually download these and use them in your final model. So you would navigate to the download section here, and you would be seeing this whole summary over here. Now you will see one point that is specific to what we've done, which is the recycled plastics eco-profiles. I'll just open this up quickly, and then I'll select which one to download. So for this showcase, I'll use the disaggregated eco-profiles in the JSON LD format. And all I have to do now is just to confirm that I've read the licenses and that I have read the EULA. When I click download, this will automatically start the download. It's fairly quick. And now I want to show you how to actually use these within an openLCA specifically. So opening up openLCA over here, I've already I've already imported a background database here. So this is the same one that we've used for the creation of these datasets, because I want to show you something that happens when I import them. So I just right-click my database, I go to import, I go to file once again, and then I can just find the dataset that I want to import here. This is the configuration that I've chosen earlier, and I will just click open over here, then select my import method. I'll just select the base method. It shouldn't matter for this. And then the import will happen. This may take a second, literally. And you will see that we now have two new categories that appear within our processes folder. There you can find first the supplementary processes. So these are processes that we created ourselves that were required for the modeling, but not available in the background database. And then you can also find the actual datasets in another folder. You'll find both a unit process and a system process folder here. So for this disaggregated demonstration, we only have the unit processes here. When we open them up, you'll see that we have a number of different datasets available here. And I just want to look more closely at the PP palette disaggregated dataset for the European average quickly. So we'll open that up, which opens the editor, and here you can see that the documentation is also fully present within the dataset. So we have further description of the process. We have a system boundary diagram here, and we also have a data quality scheme specified. You can find more documentation if you're interested in the documentation folder of openLCA. And finally, I do want to point you towards the inputs and outputs of this dataset. So you can see we imported a dataset that was not actually included in the EcoInvent database, but when we did that, we automatically imported all the inputs and outputs, but we also set the providers automatically because we were in the appropriate background database for that. So what I just want to point out is if you have an EcoInvent 3.10 license, for instance, and you use these datasets, they are automatically connected to the background database and they are fully operable as soon as you import them. Okay, and now just to show you one last thing before I move on with my presentation is I will just quickly create a product system from these just with default settings, and that should be done in a second already, and we will see how this actually connects to the background database and what information is actually contained. So you can see here, when I zoom out a little bit, that we have our EcoProfile dataset with the inventory over here, which then connects to the background database, and all these processes can create a further supply chain. I will not show this now because this is EcoInvent, but just to line it out to you, you have this perfectly connected model graph already. Now that concludes my showcase quickly, and I just want to take you back to my demonstration before we continue. Okay, thank you for following me along through that. I hope that you could basically have a good demonstration of how to apply these datasets. And now I want to summarize some of the outcomes of this research project for you, just to tell you again what is actually available to you. So first of all, we have created the methodology for the creation of average LCA datasets that you saw as on the documents page of the download section in openLCA Nexus. And we also created these 50 EcoProfiles for which we have reports, which contain a full process inventory. We have 3 different impact assessment methods. 2 of them are lifecycle inventory methods, and the last one is a lifecycle impact assessment method, EF 3.1, which we applied fully. Then the datasets that you can find on openLCA Nexus are both in ILCD format and JSON-LD format, and they come in first an aggregated configuration for use with an EcoInvent license, and also the disaggregated configuration. Now, I also just want to, for your future reference, I also just want to include where to find this exactly. So you'll find it on the EcoProfiles Recycled Plastics entry that I showed you how to navigate to, and the datasets can also be found in the download section, where you'll see this entry for the recycled plastics EcoProfiles. Now that concludes all my input for today, but I also still want to show you how we actually continue with the EcoProfiles from here, because this is an ongoing process. We are not going to stop at the first iteration, and there are still issues with our methodology that you could see we have a variation of inputs. For instance, we want to develop methods to tackle these issues. So where we do that is as part of the STOP research project, where we are currently also running a data collection effort in collaboration with individual recyclers, for which we have created a data collection template that is to be filled out by recyclers and then sent back to us. And we then provide a free LCA case study to these recyclers based on the data they have provided, and also create more EcoProfiles with the data that we collect here. Now, like I said, just now, this will also result in adaptations of the original methodology, and we'll make further changes. So this is an ongoing process. I just want to point that out. Now, last thing for me before we move on to questions and answers is just that we believe that there is potential for the application of these methodological principles to further recycled products. So we created this based on plastics recycling, many plastics polymers you can see here. We created this methodology, but we also think that it is applicable to many other recycling processes, specifically those that create products that can be readily used in place of primary produced products. Now, that concludes my input for today. It was a lot, I know. Thank you for bearing with me. And I want to move on to some questions and answers and give the attention back to my colleague, Chiara.
Thank you so much, Max, and also Julia and Jonas for the presentation. I think it was really, really interesting and super useful. It really gives a lot of additional value to have these EcoProfiles datasets, especially for free. So I'm going to share the questions that we received that were quite some. So I will quickly answer to the first one. So if the slides will be shared after the webinar. So really short answer, yes. Of course, the whole webinar has been recorded. It will be in our YouTube channel, but we also share the slides in our GreenDelta website under the resources section. But I will share the link with you, so don't worry, you will find them. So moving forward to the second question, what waste streams are considered for incoming feedstock, post-consumers or post-industrial or pre-consumer? For example, for recycled ABS, what is the source of the waste ABS? I don't know who wants to.
Maybe I can say some words. So it's actually described always in the documents and also in the data sets where it's coming from. It was very hard sometimes to distinguish between post-industrial and pre-consumer. So working on this, and the updated version, it will be better. But for that, we put it together, though we indicate where it's coming from, because some products, for instance, PVC is typically post-industrial, but others like PET is very often post-consumer. So we indicated it, and yeah, but yet LCA is also not really capable of assigning it perfectly, but though it's transparently indicated and you can see it, but we could not quantify it.
Okay, thank you very much. I hope this answered the question. Let us know, of course. So then here we have like a cluster about sorting. So sorting is not primary data, even if the recycling plant has on-site sorting, often the case. So yield loss is out of scope since sorting is not primary data. Is that correct? If collection and sorting is included in the cradle-to-gate view, how is waste in the sorting process considered? So these were the three about the sorting.
I think, Max, you can answer this quite good.
Okay, so we could often not distinguish what would be a sorting process at the recycling plant specifically. So therefore, we made the assumption that sorting processes were usually not included in the recycling plant, especially, and that sorting would have to be done off-site. And therefore, we use this secondary data set and also have included yield losses there directly. So basically, if we have a sorting of a specific waste stream, we would include, for instance, for household waste streams, we would have a sorting process. This sorting process then only produces about, let's say, for just to give you an average number, it would be like 0.4 of the input would actually be sorted into the correct recycling stream. So this is actually included in the sorting process. And then finally, the waste in the sorting process, yeah, like I said just now, the waste in the sorting process is basically considered to be then treated in a waste treatment process if we use the cradle-to-gate dataset.
Thank you. So moving on. Waste in is burden-free. I see some nodding.
Yep. Max, you can continue if you want.
Yeah,
Yep.
it's just okay. Perfect. Yeah.
Yeah.
No, Max, if you wanted to add something. Okay. Okay. Thank you. Longer question. The datasets appear to be suitable in the context of EPD creation to cover treatment processes in Module D for achieving functional equivalence of primary material. We use EcoInvent version 3.11, including the EN 15804 add-on for EPD modeling. Can we not use these datasets because they are based on version 3.10?
So there are two things that you would need to watch out for there. First of all, these are not modeled as waste treatment processes. These are modeled as production processes. So therefore, they cannot be used as a plug-in waste treatment process. And then second of all, theoretically, you can use them. You could just use the inventory that we provide in either the report, or you could use the disaggregated data set. It would then not auto-connect to the database, but you could set the connections yourself, which is not that difficult.
And it would make sense because then you connect to the latest EcoInvent 3.11.
And just to add, for the EPD modeling, so our company is also very strong with EPDs. You can actually use the gate-to-gate processes for the Model D. I just checked in with our experts on this, so that is suitable, yeah.
Okay, perfect. Thank you. And when sorting residuals are thermally treated or incinerated, how is this impact allocated? Does it count toward the first life cycle of the original product or the second life cycle as part of the recycling?
Okay, I can take this again. The sorting residues are allocated directly to the waste treatment process, not to the first life cycle, as these, in our methodology, these are wastes that are generated on site by the recycling process.
But this also, I think, makes reference when you thermally treat or incinerate something, you can get credits for electricity production or heat production. So how are these taken into account, Max?
Thank you, Julia. Sorry, I missed that detail. So these credits we fully operate on a cutoff basis, not on a credit basis. So we don't actually assign any credits to any of the outcomes of our production process.
So I think there is one more question concerning the Plex estimate. So are the results available in combination with the Plex estimate? So indeed, we added this to the PDFs about the individual eco-profiles. You can see it there, but also the ILCD ones have it. This means there is a small elementary flow called plastic littering. And of course, this can be used in that logic only with the Plex database to make it sensible, because also there is the method then to it. So, but yeah, it is added. Please have a look also in the documentation of the Plex database, which has been updated. I think it's a very nice, interesting tool to also cover this littering aspect of plastics.
And maybe to add there, if you want to make a calculation that, yeah, to include this plastic littering risk, the EcoProfiles methods that is also downloadable from Nexus has this. It is true that if you also want to include the supply chain of your model generally, it would be nice to use the Plex database, which is basically EcoInvent with plastic littering risk estimations inside. But the elementary flow and that inventory that we calculated for plastic littering risk is in all of the data sets. So that's nice.
Thank you very much. Sorry, I think I was on mute before, but thank you, Jonas, for taking the question. So I think these were all the questions that we received. And since we have just a few minutes actually before the end of the webinar, I would like to just tell you that we are actually hosting a conference in 2026, the openLCA conference, following the success of 2025 and 2024. So this is the third edition. It will be from the 21st to the 23rd of April in Berlin. And as of now, the abstract submission is open. So if you are interested in participating, in submitting your abstract, please, we wait for you. Of course, we also leave the link here in case you wanted to take a look. And we really hope to see you there.
Actually, maybe specifically T3 session is for the evaluating the sustainability of plastics. So that's the session that is relevant for maybe everyone doing plastics, but also we have quite some sessions on dataset development, databases, etc.
Yeah. So we really hope to see the whole community there. So I think this brings us to the end of this webinar. I think it was really interesting, and I really would like to thank Max, Julia, and Jonas for the presentation. So we wait for you at the next webinar, and indeed I will send a follow-up email with some useful resources for you. And again, thank you for participating, and thank you again to my colleagues as well.
Thank you. Bye-bye.
Thanks a lot.
Thank you. Goodbye.
Bye, everyone.